Hello everyone, it's Salar and this is a tutorial for writing a real-time operating system for embedded system and Cortex-M microcontroller. And this is part 16. And according to the previous agreement in previous part, in this part, I wanna create a project for our work by CMSIS, And what's CMSIS? What's CMSIS? Let's open the digital open software and give some information about CMSIS. CMSIS. This term stands for Cortex Microcontroller Software Interface Standard. Software Interface Standard. Okay, standard. But what's Cortex? Cortex is a some library and some header file that related to Cortex-M microcontroller and sometimes for some of Cortex-A microcontroller. Okay, but mainly it has been used for Cortex-M microcontroller. Okay, Cortex-M microcontroller. But what's CMSIS and what is software interface standard? Cortex is a some file and library from ARM company. Okay, from ARM company, manufacturer that creates ARM architecture. Okay, and CMSIS defines a standard to create more portable program. Okay, to create more portable programs. Why we need more portable programs? Because ARM company is not a foundry and it's not a chip maker. ARM company just create the structure of core, your architecture, and instruction set. But other companies like ST Microelectronic, NXP, Texas Instrument, and other companies, for example, Renesas, Cypress, and other companies in all of the world can use this core and this cores from ARM and create its own microcontroller. So we have a variety part of microcontrollers from a lot of companies in the world. Okay, and we need a portability between these microcontrollers because, for example, I want to write a real-time operating system and I want to port my real-time operating system to all of these microcontrollers. Okay, to all of these microcontrollers. So I need a portable standard to port my operating system to that. Okay, to that standard. So when my operating system is based on CMSIS, I'm sure that my operating system can be ported to all of microcontrollers. Okay, so we need a standard to create more portable programs. But how can I download CMSIS? Let's open my web browser and search for CMSIS GitHub. Okay, you can download CMSIS from GitHub because it's an open source project. And here, ARM software CMSIS version 5, the last version of CMSIS. And here is the CMSIS, and you can download the last version from here. Okay, click on code, and you can clone with terminal or you can download with zip. Okay, I want to download with zip. And when you download, let's pause it because I have downloaded this file before. You can have CMSIS in your download. Okay, here you will have CMSIS. Okay, it's compressed file, and you can zip file, uncompress and extract your project, your CMSIS document to your computer. And I've extracted the CMSIS in my home directory. Okay, in my home directory here I have CMSIS file develop. Here is CMSIS. And so what's the all part of CMSIS? What's the all part of CMSIS? Let's do describe it here. Let's describe it here. As you can see, when you have a microcontroller, for example, assume that you have a microcontroller like this. Okay, when you have a microcontroller, your microcontroller has two main parts. Okay, two main parts and some other important main parts. One of the main part is your core. Okay, one of your main part is your core, and another is your peripherals. Okay, another your peripherals, and other parts, for example, your system bus and your memories in your microcontroller. Okay, so when you have a microcontroller, you have some main part. One of main part is core. For example, core M7. Okay, and you have some peripherals. You have some peripherals in your microcontroller. In your core, you can have some subparts. Okay, for example, you can have some subparts, and in peripheral, you can have some subparts too. Okay, for example, in your core, you have your processor core, for example, Cortex M7. You can have some subpart, for example, for controlling interrupt, NVIC in Cortex and microcontroller, some part for memory protection unit, and some other port, for example, for debug and others. And in your peripheral, for example, you can have some I/O ports, you can have some serial ports, some port for analog to digital converting, and other ports. Okay, it's known as core and it's known as peripherals. Okay, it's known as peripherals. CMSIS has some files for your core and your peripherals in your microcontroller. Okay, for your core and your peripherals in your controller. But the core part, okay, the core part, if you open CMSIS folder directory and open CMSIS, you have a core. Okay, it's for core Cortex M, but you have a core for Cortex A that it's not so famous, it's not so useful, but here is so important, a core. Okay, what's core part in CMSIS? Core. In core you have some header files. You have some header files that related to core parts. What's core parts? For example, your controlling memory protection unit, your interrupt, your debug, some for example, your other parts. Okay, all of your parts that you have in your core, and some header related to your compiler. Okay, some related to your compiler, as you can see in CMSIS core. And include templates, not so important. Okay, include is so important. You have some header files, for example, for Cortex M7, M4, M30, M35. For your compiler, for example, if you use GCC compiler, you can use this file, okay? Some header file that you can use them, okay? And in your header file you have some functions and definitions that you can use in your project, okay? This is core part. But in CMSIS there is another part that's known as driver, okay? That's known as driver. What's driver? Some header file files and source templates. But in this time is related to your prefab, okay? Is related to your preference, okay? It's related to your preference, to preferred part, okay? Here is preferred part, but often has not observed by chip manufacturer this standard, okay? This driver, header file and templates, let's to see that in CMSIS and driver, okay? Driver. There is some include, for example, for USB part, Ethernet part, flash, I2C, and other things. It's not a major part in CMSIS because often not observed by chip manufacturers like companies like STM and NXP, because different chips have different peripherals, okay? For example, your UART and serial port in STM32 is different with the serial part in NXP microcontroller. So because of these differences, many of chip manufacturers have not observed the standard of driver, okay, and they have their own driver part. For example, for STM32 Cube, or for example in NXP NPC MCU Express, or for example in Nordic Semiconductor and in Microchip and other companies, you have some SDKs for their peripherals, okay? Because different microcontrollers have different peripherals, many of chip manufacturers often have not observed this standard, okay, driver. But because the core of all these microcontrollers are identical and are similar and are, for example, Cortex M743 or other core, the core part can be used and will be used for all of microcontrollers, okay? But you can't use driver for all of your microcontrollers and your boards. But there is another part in CMSIS, as you can see, the device, okay? The device. So what's device and what does have the device part, okay? The device part. Device part has some basic files. Some basic files to create a basic project in all compilers, okay? Almost in all compilers, in some most important compilers. But what's these files? You got familiar with two of these files. One of that is a startup file, okay? You can have startup file in C or assembly mode in CMSIS. So you can find your startup file for your specific core in CMSIS device, okay? In CMSIS device. as you can see in device, the ARM directory, and your core. For example, my core is Cortex M7. Okay, for example, here is core M7, my core Cortex M4, M3, M1, and other microcontrollers, M23 and other. Okay, for example, for my core M7 in source, okay, in source and your compiler, GCC, you can find your startup file, startup assembly file, okay, that it will be used and it can be used for all of microcontroller that have Cortex M7 core. Okay, in the previous part, for example, I downloaded a startup file from STM32Cube, or for example from NXP website or other. And for example, if you have a startup file for ST microelectronic microcontroller, you can use this file just for ST microelectronic, that microcontroller that you download the file. Okay, but if you use this file, you can use the startup for all of microcontrollers that have Cortex M7 core. Okay, you have another startup file that is in C, but most of the time we use assembly file. Okay, use assembly file. You can C file for your project. It's do the same work as assembly file, but many of time we use assembly file. Okay, you have another file in your device directory and is linker script for your compiler. Okay, for your compiler. Another time in Cortex, in device, ARM, your core, source, and your compiler. Okay, you can the linker script for GCC compiler here, that you can use this file for all of Cortex M7 microcontroller. Or if you, for example, you use ARM compiler, you can find a scatter file from here. Okay, your startup for your compiler or your compiler. Okay, you can find a startup, but for GCC and ARM, you can find your linker script that in ARM compiler known as a scatter file, but we will use and we have used GCC for our project. Okay, you can find another important file in device, and it's known as peripheral header. Peripheral header. What's this header file? This header file will map your register in your microcontroller to some define, struct, and some macros. Okay, in this file you will have your register that map to some struct and defines. Okay, how can I find this file? Another time in CMSIS, device, ARM, your core, in this time in include. Okay, in include you can find your header file that start with name of your core. Okay, with name of your core. For example, here ARM CM7, ARM CM7 underline DP or underline SP. It's like this file, but if you want to use single precision floating point part of your microcontroller, single precision floating point part, you can use this header file. If you want to use double precision floating point unit, you can use this file. But if you don't want to use floating point unit, you can use this file. Okay, all of this file can be used for your project. Or for example, for Cortex M4 in include, you can find these header files. that start with name of your core arm cm4 that you can use this file to use floating point unit fp. Okay, these two files that start with name of your microcontroller known as peripheral header, core peripheral access layer. Okay, core peripheral access layer file. It's a file. But when you use this file from CMSIS, you will not have the peripheral access. Okay, in this file, CMSIS has not defined the peripheral part of your, because different Cortex and microcontroller have different peripheral part. Okay, but if you see this file, for example, in STM32Cube repository, driver, CMSIS, device, st, include, here, for example, for my microcontroller F746, you will have a big file. The file has 17,000, 18,000 lines. Okay, and it's known as another time CMSIS device peripheral access layer. It's like this file, but this file is dedicated just to STM32F46, and in this file you have all of your core part, interrupt part of your microcontroller, and your peripherals. Okay, for example, CAN peripheral, DMA, GPIO, clock controlling, and other things. Okay, I know this file is more mature, is better to use, but because I want to create a more portable project, I will use this file from CMSIS. Okay, this file has no information about your peripherals and is a little file. Okay, it's a little file and has no information about your peripheral. But when we use this file for my project is more it's startup.c. It's startup.c. CMSIS device ARM CM7 include here. Okay, here is my file. Okay, when I use this file instead of this file, I don't have information about my peripherals. Okay, but when I use this file, you can have a more portable project for all of Cortex M microcontroller. Okay, not just dedicated to one chip, for example, from ST Microelectronic. Okay, so I will use this file from CMSIS, not from STM Cube or MCU Expresso or other chip manufacturer libraries. Okay, so you have some important part: startup, linker script, peripheral header, and system init. As I said in previous part, you need to define a system init for your microcontroller. But if you use CMSIS, you will have this file in CMSIS, system init or system init function. Okay, you will have this file in your project. But how can I create a project? How can I create a project with CMSIS? To create a project with CMSIS, create a project by CMSIS, you need to do some works. First is download CMSIS. download CMSIS. You can download CMSIS from GitHub, and I've downloaded this file and CMSIS from GitHub. Okay, you should download CMSIS and have CMSIS in your computer. Okay, after that you need to copy some directory and some part of CMSIS in your project. Okay, what part? CMSIS part and device part. Okay, CMSIS part and device part. What's CMSIS part and device part? In CMSIS develops CMSIS part and device part. Okay, let's do make a directory for my project. Make a directory, for example, first CMSIS. Okay, now let's copy these two files from home CMSIS develop these two directory. Copy these directories, return to home, and go to your project and directory first CMSIS here. Okay, and paste it in your project. Sorry, CMSIS and device. Okay, you have now CMSIS and device. You can just copy core part, but I've copied all of CMSIS part and device. Okay, after that you need to create a function in a C file. Create a function in C file and add main function to your file. Okay, you need main function. So nano, for example, main.c, and in main.c add main, and you can, as I said, you can define your main with a void, return type when you write your program as a bare metal program. Main function. Okay, here is your main function, and this time is contentless, but you need the main function. You can't define, for example, main1 or other name. You should define main function. This name is so important. Okay, save your file. Now I have a let's do cd to first CMSIS, and in this project create your main function. I've created main function here in my okay, cut this file and paste it here. Okay, now I have main function in my project. Okay, in a file. The name of this file is not important. You can have another name. For example, you can have solar, but the name of function is important, main. Okay. After that, you should add your peripheral access header file. What's peripheral access? Here, your peripheral header access to your project. Okay, for example, here for my Cortex M7 is ARM CM7.h. You can have, for example, M3, M4, or other microcontroller, but my chip core is Cortex M7. Okay, you should add this header file in your project. Let's just save that. So you have a main.c file, you have a main function, and you have your include part of your file. Okay, ARM CM7. As you saw in device and ARM, your code, for example, for Cortex M3 include your header is just Cortex M3. Okay, just Cortex M3, but for Cortex M7 you can add one of these files, okay, but I added this ARM Cortex M7.h, okay, but you can add one of these files, okay, but I just want Cortex M7 without floating point unit. So after that, but before that, after that you add main function. You need to add include header. What's the name? ARM CMX. X means 1347.h. Okay, you need include this part in your code. Okay, or for example, you can add, for example, ARM CM7 underline single precision. Okay, all of this header file you can add to your project, but in this time I have added ARM CM7.h. okay, this time I added this header in my project. But when you add ARM cmx.h in your file, this header file will include other header file in your project. What is core underline cmx? Cmx means name number of your core dot h, and another header file that is system underline underscore arm cmx.h. okay, a header file for your system init function, So when you add, for example, arm cm7, this file will add this header file system arm cm7.h. okay, as you can see, it will add system arm cm7h and this time core cm7. Where is this file? This file is here in CMSIS core include. Okay, core m7. We'll add this file and add all of, and this file will add other part of this include headers in your project, and with this header you added CMSIS in your project. Okay, CMSIS in your project, but we need to do some other works for compile and link or program. Okay, for compile and link or program, we need to do some other works. Let's split this part. You need to do some other works for compile and link. What should you do? What should we do? As you have seen in CMSIS device, ARM, your core, source, and your compiler, you have a linker script file. And you should adjust this file for your specific microcontroller, microcontroller. Change linker script file. Okay, the next work that we should do and we have to do is adjust linker script file to your specific MCU. Okay, so what should I do to adjust? You should set the size the start address and size of your specific flash and RAM. What's the start address and size of my microcontroller, and how can I set these values in linker script? Another time in my go to Solar, my project. Another time in my project, go to device, go to ARM, your core, include source, GCC, and linker script. You have some variables in this file. One of that is RAM base and RAM size. RAM base and RAM size. RAM base and RAM size is size of and base address of your flash memory. What's the flash memory in my microcontroller? Flash memory is a non-volatile and permanent memory that you can save your code and your program in that. And what's the RAM? You have two other variables, RAM base and RAM size. Okay, RAM base and RAM size here. RAM base and RAM size, RAM base and RAM size. RAM is a random access memory and your volatile memory that you can save your data in your RAM, in your chip, your microcontroller, and when you turn off your microcontroller, your RAM will be deleted. Okay, it's this difference of ROM and RAM. Your ROM in your microcontroller is a flash and your RAM is your volatile memory. And as you can see, the linker script will use the RAM base and RAM size for your flash part, and RAM base and RAM size for your RAM part. Okay, but it's a simple linker script. I said that I will teach you how you can write your specific linker script for your project. Okay, because sometimes you have not just one RAM in your chip. Okay, for example, you can have your internal RAM and external RAM, and if you want to use all power of your microcontroller, you should add all of your RAM and flash parts in your linker script. But this linker script is a simple linker script that you can add just one part of flash and one part of your RAM in your linker script. Okay, so how can I find RAM base, RAM size, RAM base and RAM size of my microcontroller? So how can I find that? You should download your datasheet or reference manual from your chip manufacturer website. Okay, I've downloaded some PDF from some websites and I have those here, these files. Let's copy them and let's take it to my project. Okay, for example, here is a reference manual for Cortex M Cortex F7 from Estimation Electronic. In this file, you should search for memory map. Okay, memory map, memory organization here, and in that go to your memory map. Here is add all parts of your memory in your microcontroller. So how can I find my flash between all of these parts? For example, here, this part is your flash. What's ITCM flash for? What's a AXCM flash? In this part, we will use this flash. Okay, as you can see, you have, for example, two parts of your flash, but for a simple project, just use this part in my project. And a start address is here. Start address is here. Is a hexadecimal, and the end of address is here. Okay, end of address is here. For example, here, a start of your flash address is here. Let's do copy that and go to your ROM base and paste it here. Sorry, let's do write it by myself. 0x080000. Okay, it's the ROM base. 08 and 0000. As you can see here, zero eight zero 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 zero. Okay, and the size of your flash part is here, from 08 to here, F. Okay, F is a hexadecimal, and from 0 to this. Let's to open that. For example, ROM base or ROM start address is 0x08000000, and your ROM size, it's 2. The end of address is 0x0800. No. 080FFFF. If you add a 1 to this part, the size of your part is 10000. This part plus 1. Okay, because you start your size from 0 to F is this size. Okay, in hexadecimal form. So the ROM size is 0x 0010 0000. Okay, it's the ROM size. Okay, and another time for your RAM size, and RAM base. Your RAM base is here, and you have 3 continuously RAM, because all of your RAM part is continuously. You can add all of these parts in RAM, but your flash part is not continuously, so you can just add one of those. Okay, but this time you can start from here to here. Okay, so a start address is 2 and other numbers is 0. Let's write that for RAM size, and it's, you don't need to change that because it's true. Okay, and the end address is 4FFFF, okay, and 4FFFF plus 1, 4FFF plus 1 is 5 and 40, okay. Another time for RAM, sorry, for your RAM, it's for your flash, okay. Let's start from 0x to 0, 0, 0, 0, 2, 2, 0, 0, 4, F, 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 and this part plus 1 is the size. It's the start base, and the size is 50000, okay. So the size of your microcontroller RAM is here, okay, and you need to do these changes in your linker script. But if you have another microcontroller, for example NXP, from NXP, you can find the RAM base, RAM size, and RAM base and RAM size of your microcontroller another time in memory map, okay. Here you can find all of your memory parts, okay, all of your memory parts here. But it's a hard work for a basic engineer and a junior engineer in microcontroller to find these parts in data sheets. For example, for another microcontroller from Nordic Semi, another time you can search for memory map. And it's so hard for a basic engineer to find the address and RAM base and RAM size of your file from this data sheets, and you don't know information about all part of your linker script. Because of that, I will create a file that the name of file is link flash ram.txt, and I will put it in my GitHub, in GitHub of my project, and you can download this file from my GitHub. I will say you what's the name of my GitHub repository and what's the address of my GitHub. I will put this file in my GitHub and you can download that, and I will put a list of famous microcontroller and board that their core is Cortex-M, and I will put this number, RAM base, RAM size, RAM base, RAM size of some microcontrollers, some famous microcontroller in this site, in this text file. And if you will be lucky, you can find your microcontroller RAM base and RAM size of your microcontroller to this file. But if you will not find your microcontroller RAM size and RAM size of your microcontroller to this file, don't worry. I will teach you how you can write your linker script in future parts, okay? So don't worry. But I will put some famous microcontroller and board linker script RAM size and RAM size in this file. So I've changed this number for my microcontroller, okay, for my microcontroller. Let's just save that. You can find these numbers, for example, in your package from your company. For example, STM32Cube repository, and here in driver, in project, for example, for STM32, it's my board examples. For example, in ADC, Here you can find some of these numbers. Okay, for example, here the RAM based, RAM size, RAM based, and RAM size. Okay, you can find these numbers from your linker script, file, from your chip manufacturer package. Okay, it's another way to find these numbers. One of the best way is to find from your data sheet. Another way is find from your linker script in your package. Okay, or for example, for NXP, you can find, for example, from NXP device and GCC, you can find your linker script and you can find these parts. For example, you have 4 parts, but 2 main parts it takes. That's another name of your flash, and it's the base and size, and it's one of your RAM part. Okay, base size. You can just add to this part for your microcontroller. So another way is to find your memory address from your package, from your chip manufacturer website. Another way is from datasheet, but sometimes you want to add for example, a SDRAM. Okay, SDRAM to your board. You will add the address of your SDRAM to your linker script, but this information and these issues is more professional, and I will teach about them in future parts. Okay, but in this time you need just change your linker script, and as you can see here in my project, device, ARM Cortex M7 source GCC. I've changed the RAM base, RAM size, RAM base, and RAM size of my linker script file. And in this time, you can add this linker script to your project. And in this way, my project is portable to all of Cortex and microcontroller. Okay. So after that, you need to create a make file. Create a make file for your project. Let's close that. Let's close that. And close all of these files and back to my project. Okay, and back to my project. Here is my project, and in this time I should create a make file to compile my project. Okay, in this time I've created my make file, and let's see what's in my make file. You need to add 3 files for compiling. One of that is your main file. Another is your system core file that contains your system init function. Okay, where is this file? In device ARM CM7 source. Here you should add the name of this file for compiling, system ARM CM7. In this time, for example, cm7.c. You need to compile this file for your project. Here is system ARM CM7, and it's the name of my object file. Okay, that created from this file by this rule. Okay, you need to compile this file. So one of your rules is for main, another is for your system file, and another is your startup file. You can add your startup.c file or a startup.s file, but I've added assembly file to my project. Startup underscore name of your core, Cortex CM7. Okay, Cortex CM7. Another rule is for your startup file, assembly file. This file is assembly with uppercase S. Okay, in this time with uppercase S. And you should compile these files and create an object from these files, and in your default goal link all of these object files. Okay, but we need to add the path of your file to your make file with vpath. ARM CM7, if you have, for example, ARM Cortex M4, you should add ARM Cortex M4. This time Cortex M7. Device ARM Cortex M7 source and GCC. Okay, where is these two directories? My project. Device ARM, your core, source, address of this file, and your compiler. Okay, source and GCC. I've added source and GCC for C file and assembly files. Okay, source for C file and assembly file, GCC for C file and assembly file. But you need to add a define here for your compiling stage. -d ARM CM7, name of your microcontroller. What should I add this definition in my compiling? Because I need that in system file, systemc. You can here, if you defined this definition, we'll add this header file to this file. If you define this part for single precision or for double precision, and if you don't add these definitions, one of these definitions, it will return you an error. Okay, so if you want to don't have error for your compiling, when you compiling, you need add one of these definitions. For example, here Cortex CM7 for your project. Okay, and if you have, for example, another device, for example, Cortex M4 in source system, you will add one of these CM4 and floating point unit. Okay, if you don't add this definition, you will have this error in your output, compile output. Okay, you will have this out, and in your system file you will have your system init function. Okay, and you don't need to add the system init to your files by yourself, because CMSIS has defined this file. Okay, so let's go to my after adjust your linker script, you will add create a make file. You will add to your make file vpath for your, for example, star for your C file, or for your, for example, assembly file, as I added in my, and you need to add a definition -d ARM CMX ARM CMX. Okay, one of definition that you want, or for example -d ARM CM4 underline floating point unit. Okay, and according to your chip and according to you that you want, you should add one of this definition to your compiler. Okay, as you can see in make file, I added -d -d ARM CM7 -d ARM CM7 and -d ARM CM7. Okay, and you should add your include path, and you should add your include path. Include path with -i. You need two include paths. One of that is CMSIS core include. Pay attention that here is capital C or here is capital I. or all of the letter of this term is capital. Okay, you should add -i and another time -i and include path of your device. Sorry, ARM, your core, for example, ARM CM7, for example, 7, and include. Another time, pay attention to this letter is capital I, and here is capital D, and all of the letter of this name ARM and ARM CM7 is capital. Okay, you should add this to include directory for your command. CMSIS core include, CMSIS device ARM CM7 include, for example, for Cortex M7. Okay, and for your output file link stage, you should add the address of your linker script that you add just for your microcontroller. Device ARM CM7 source GCC ARM.ld. Okay, and all other options, it's like a previous part. For example, specs file -o -mthumb, your CPU name, Cortex M7, and other things. Okay, and here is your makefile, and with this makefile you can compile your project. Okay, you can compile your project. So let's do compile the project. Control X, ls. I have some files. It's my PDF, not important. I have CMSIS and device part. I have my main C file. I have my make file. And first make clean. And another time make your project. Make for make your project. Now I've created and I've compiled my file, and I link my file, and I have no error. I have no error, and I've compiled my project with CMSIS. As you can see, I have some line with info for some information about linking. For example, info link all project. This adds some info in my terminals. Okay, so first compile main file and create main.o. After that, compile your system file from this file and create system.o, system_arm cm7.o. And after that, compile your assembly file, assembly startup file. After that, link all of these files. And create your output. Output.elf. Like previous section, I have my output elf. But in this time, my project is completely practical. And if I open main C, you can write your program here, and flash your output file to your microcontroller and see the output in your microcontroller. It's completely practical. You can now write your code. For example, turn on an LED here and flash your output file to your microcontroller. Okay, but for this part is enough, and in the next part I will create a program for my microcontroller and turn on an LED on my board and flash my program to my microcontroller and debug my program with ARM debugger. Okay, so now with this structure, let's delete these files. With this structure, CMSIS device, your main file, here your main file, and your make file. Here is your make file. You have a completely practical project, and you can add your code to your main file, compile and link your project, and flash your program to your board. Okay, without any error. So enough for this part. Thank you very much to see me, and see you soon in the next part. Thank you.